All right, let's take a look at our problem here. So we have a plane traveling at 300 kilometers per hour, the heading at 110 degrees, and a wind coming from 250 degrees at 30 kilometers per hour. We want to find the bearing and speed of the plane's resultant travel. Resultant makes me think of vectors. All right, let's look at an illustration here. Remember now, we're talking about bearings. North is 0 degrees, and we count clockwise from there. All right, here's our heading, 300 kilometers per hour, 110 degrees from north. Here's our wind. Okay, let's just pause it for a second here. It says that the wind comes from 250. Okay, so if I understand that correctly, the direction of the wind is 250 minus 180. Okay, and so we're interested in this angle here, which would be the bearing. So that would be 70. Okay, now I want to draw the wind vector from the end of the heading. All right. Now, there are a couple different ways to think about this. One is you could just take the position vector of the heading and the wind, add them together, okay, and you can get this point. Think of an XY plane. You can get this point, and then the resultant is the position vector of these two vectors added together. So if you have the XY value of this point, then you can get the magnitude and the angle, and then from there the bearing. Okay, so that's one way to do it. Another way, which I think is a bit easier, is to use the cosine rule and the sine rule. Okay, now I always tell my students that when there's more than one way to solve a problem, do it those ways, okay, and match the answer. If you don't match, then you know you have a problem with one of the methods, okay? And this will reinforce your learning, and it will also inform your decision about what method is the best for you, what one's easiest, what one's the fastest. Okay. It's just a great practice to do things more than one way. Okay, but I'm going to use the cosine rule, and for that, we want this angle theta, okay, which is between the blue and the orange vector, right there. Okay, so hopefully you can see how we can calculate that if we know those two angles of the vectors. Okay, so what we're looking for is the purple vector. That's our bearing. Okay, so the magnitude of that vector, I'm calling it A, and we're using the cosine rule, looks like that. Okay, so slow it down and do that calculation. You'll see that you get approximately that. That's a bit more than the original speed, so the wind is helping. Okay, now we want the bearing of the purple vector, and so that's going to be 110 minus the small angle, which I'm calling phi, which is the angle between the purple and the blue vector, okay? So it's 110 minus that small angle, and we can calculate the small angle using the sine rule. We have all the information we need to get the sine rule. Okay, so actually pause it and try to do that now. This is what you get for phi. Okay, we're expecting a small angle here. Okay, so only 3.42 degrees. And so we, to get the bearing, we take 110 minus that. And that's it. Okay. So like I said, try to do it a different way and get the same answer. That would really build confidence. Okay, hope that was helpful.